on a quiz that I took earlier in Math Excel.
Okay.
In math, we take a quiz in Math Excel, and we can take it multiple times.
Okay.
But we until we get 100, but we keep on taking it so we can learn the material.
I kind of like that technique. So what's the first problem you want to work on?
15 over 2x plus 6 over 7 equals 3 over 2x.
Okay.
And then it wants to find x.
Right. You might be tempted to find a common denominator and do that process.
That's exactly what I did.
Well, notice that there's an easier step. If I bring this 3 over 2x to the left side by subtracting it from both sides, now I can actually operate. I got 15 over 2x minus 3 over 2x. That's got the same common denominator.
Actually, I did do that to get 12x.
Okay, well, to get 12 over 2x, take the number on the other side like that. Now, simplify that. What is that again?
12 over 2x.
Equals minus 6 over 7.
Since right here's where I struggled.
Well, since whether the variable's in the denominator or the numerator, you can always cross multiply. When you have one rational fraction with a single numerator and a single denominator term equals another rational quotient, then cross multiply. Cross multiplying is just one step in two. In other words, what I could also do here is multiply both sides by 2x and then multiply both sides by 7. That gets rid of all denominators. Well, I do that in one step. It's called cross multiplication, but it's really two steps. You see that? So I get minus 12x equals 84. What's x equal?
Oh, 7.
Minus 7.
Negative 7.
Okay. And notice that it would have been a lot harder if I'd have had to find a common denominator, which would have been 14x. And when I would have had to determine what that number is with 2x as the denominator. So always look for easier ways to do the problem. And certainly this was easier by bringing everything with x over it on the left side, everything without x in it on the right side. That's usually, at some stage of solving an equation, that's a step.
Right.
Gather all your variables on one side, all your numbers on another. And then if this doesn't happen to be 2x, then you might have to find a common denominator to combine those two terms. But since it's 2x, it's particularly advantageous to do that.
I had the 12 over 2x part right, but then I had 12 over 2x plus 6 over 7, and then from there I made it a common denominator of 14x.
Well, okay, let's talk about that. You got it to this step, which is a correct step, right? Don't forget to put the 0 on the other side. Because when you've subtracted 3 over 2x from the right side, you left 0. Okay? Right. Now, there's a couple of ways to solve that. I can combine those two, and that would be equal to 0. But why not just move the number to the other side? Almost always, when you're solving equations, think of that. If you're solving one variable equations where there's only an x, there's no y or nothing else, get everything with x in it on the left side, get all your numbers on the other side. Then it becomes a piece of cake to solve.
Okay.
Okay? Let's do another one to test you.
8 over 7 minus 3 over p.
P as in Paul?
Right. Equals 6p minus 7 divided by 7p.
Okay. Now, notice that if I wanted to combine these two over here, what's the common denominator?
7p.
Right. So I could do that, and then I'm going to have a 7p in my denominator on both sides of the equation, and the problem's going to become easy. In other words, once I get, let's say I had 16 over 7p equals 6p minus 7 over 7p. Well, when you end up with that, what statement can you make now?
Now you can cross multiply.
Well, you don't need to. That would be a lot of algebra that you'd have to then simplify. The fact is if they both have the same denominator, then their numerators have to be equal. So the statement you can make is that 16 would have to be equal to 6p minus 7, which makes the problem a lot easier. Okay? So we could do it that way. In other words, we could find the common denominator and then equate the numerators. Whatever numerator I get over here, and there is going to be a p in it, it's going to be equal to that. So that's not a bad way to do it. Let me show you another way that I prefer. In that, I'm going to multiply both sides of the equation by 7p. Why? To get rid of denominators. Denominators is what makes equations hard. But if you get rid of all the denominators, and I'm going to get rid of all of them in one step, what's the first term on the left?
8 over 7.
No, the 7's cancel. What's p times 8?
8p.
Okay. Now multiply the 7p times this thing. What do you get?
7p? Or 7p squared?
Hold on. I'm multiplying 7p times minus 3 over p. So 7p multiplied by 3 over p. What happens to the p's?
They cancel.
And you're left with?
5.
21.
Perfect.
7 times 3.
Oh, I'm sorry. I thought that was a minus.
Okay. So that's what happens to the left side of the equation. What happens to the right side is even that cancels with both, and I'm left with 6p minus 7. Now, isn't this equation a whole lot easier looking to solve than what we started with?
Mm-hmm.
And I did it all in one step. It's a little bit of a advanced step, where if you can find a common denominator that rids you of all denominators in one step, that's usually a good step to take. Because now I'm going to move the p's to the left. The next step in solving this is to move the variables to the left and move the numbers to the right. And you don't have to do it left and right. You can do it right and left. But the key is separating them. Get one on one side of the equation, the numbers on the other. So p has to be 7.
Right.
Okay. Now, let's just look real quick at how we would do this the traditional way and see if it's easier or harder. Well, it's going to be maybe easier. Common denominator is going to be 7p. What goes here?
7p, and now would be 8p.
And what goes here?
21. And this is the way I set it up.
Yeah.
I was solving.
And this works just fine. Now, notice that if this is true, my denominators are the same, right? So I can actually write it like this. Okay, so I have this is equal to that. And always be looking for these little things that make the problem much easier to solve. If you cross multiply, you make it much more complicated. But if you realize, wow, I have the same denominator, that means my numerator has to be the same. There's no way these two things can be equal if my denominators are the same without my numerators being the same. So now I can get to the same place I got with about the same amount of math. But you have to realize that you're looking at a special situation here where the denominators are the same, therefore equate the numerators.
Mm-hmm. So if the numerators or the denominators are the same, I can kind of just
the numerators have to be the same. And vice versa. If I tell you that x over 7 equals x over y, what does y have to be?
7.
Yeah, it can't be anything else. So whenever one side of the fraction bar is the same as the other side on the other side of the equation, just equate the others and you solve it instantly. As opposed to cross multiplying and then I get this, and now I gotta subtract that, so I get xy minus 7x equals 0. Now I gotta factor an x out. All kinds of strange things happen. So recognize that fact. What else you got?
4 over 3 parentheses c plus 6.
I'm sorry, c plus 6?
Yeah, c is in cat. End of parentheses and then plus 1, whole number 1, equals 2c over c plus 6.
Again, the very first thing I notice is that this is almost a common denominator in both terms. What do I have to multiply both sides by to get rid of all the denominators I'm looking at?
C plus 6.
Times 3. If I want to get rid of this 3. So I'm going to multiply, and this is a technique that not everybody uses, but I happen to like because it simplifies it in one step, even if it's a tough step.
Wouldn't multiplying the other denominator that doesn't have the 3 times c plus 6 mess it up, though?
No, watch what happens. I've got to multiply. In other words, I can do anything I want to the left side as long as I do it to the right side. Okay, so all I'm doing is multiplying both sides of the equation by 3 times c plus 6. Well, that cancels with that, leaving 4. This times this is 3c plus 18. We'll go ahead and distribute it. You with me?
Mm-hmm.
Over here, that c plus 6 cancels with that c plus 6, and I'm left with 6c. Now, that is super easy to solve from there.
Right.
And it was only one step to do it. Now, what you have to be careful with is when you use this technique, you have to make sure that whatever you multiply both sides of the equation by, that you multiply all terms. In other words, a lot of people might forget to multiply that by the 1, but you have to do it because I'm multiplying the entire left side of the equation by this and the entire right side by that. But even though I have to do that, it still turns it into a far nicer looking, easy to solve equation almost instantly.
So where did the 3c plus 6 go when you multiplied it by the 1?
Right here.
Okay.
I distributed
Oh, I see.
I
Drop down.
distributed it at the same time. At some point, you're going to have to distribute it. I just did it all in one step.
Okay.
Okay? Then you get 22 equals 3c. C equals 22 divided by 3. Now, there's a couple of other things I could have done that are a little more complicated than that. I could bring this term to the left side and then combine it with this term, and then my common denominator, just have to multiply that by 3, right? In other words, if I multiply the right top and bottom by 3, which I'm allowed to do, turns the right side into 6c over 3 times c plus 6. Now that looks an awful lot like that, same common denominator. So let's move that all the way to the left. Well, now I have on the left side 4 minus 6c all over that. And I'm going to move my 1 to the right side, equals negative 1. So now I have to solve that equation. Okay? So even though I just put quite a bit of work in to making this denominator look like this, I still have not a difficult problem, but it's not as easy as what I had on the second step before. What's the next step in solving that right there?
Then you would, could you cross multiply and just get rid of the 1?
Not really cross-multiplying. Cross-multiplying is a term that's used when you have a fraction equals a fraction. In this case, all I need to do is multiply both sides by that denominator, right? And I will leave on the left side 4 minus 6c, and on the right side minus 1 times 3c plus 18. Now I get the same solution. I still get c equals 22 over 3. And to me, it was a harder problem doing it this way.
Yeah.
And it even still required a little bit of thinking out of the box. In other words, there's a moment of creativity that's needed here to know to multiply that by 3 over 3 so that I will have a denominator that's the same as this denominator. And then moving the whole thing over to the left side to produce this, well, I still have a fraction. And fractions make equations harder to solve. They just do. So my goal when I'm trying to solve any kind of an equation, I got 2 initial steps. Get rid of the denominators and then get rid of your parentheses and go from there. And it's hard to go wrong if you do that. There's a few places where that doesn't necessarily work. If you have something like this, well, the first thing I want to do here is expand that. So get rid of your exponents. So the 3 things to get rid of are denominators, exponents, and parentheses. When I get rid of this exponent, I also get rid of the parentheses. So those frequently go hand in hand. But always think about getting rid of denominators. I saw a real clever problem once that was 2x over 7 minus x squared over 5 equals x plus 3 over 35. What's the best first step to do to solve this equation?
Well, they all have the 7 goes into all of them, and so we would make it a common denominator of 35.
Okay. What am I going to do with it?
And then after you make everything the denominator of 35.
No. I have found the number 35 that if I multiply both sides of the equation by 35, all my denominators are going to go away. That's the trick. You need to find the least common denominator between these 3 denominators. There.
And if I
multiply by 35, both sides of the equation. Well, what's this term?
That's just going to be 2x, right?
Well, it's 35 divided by 7 is 5, so it's 5 times 2x. Make sure you see that.
Okay.
What's this next term? What's 35 times this?
That's going to be 7x squared.
Correct? And then on the right side, what do I have?
X plus 3.
Now it's an easy problem. Now it's a simple quadratic. Get everything on one side of the equation, set the other to 0, and solve your quadratic the way you would normally solve a quadratic. But notice that first step. Always look and see if I can multiply both sides of the equation by the same number or the same variable. Frequently, that's the best first step. It clears up the problem immediately, as long as you know how to do that. In other words, as long as you can multiply 35 times 2x over 7 and 35 times x squared over 5, you got to be able to do that. But you can see that's not that hard.
Yeah.
In other words, if I gave you this math problem, you don't ever want to multiply the numerator and divide by the denominator. You always want to see if you can simplify. Well, I can divide top and bottom by 7, leaving 1 and 7, or 5 right there. And now it's 5 times 2, 10. I never had to deal with a number greater than 10. As opposed to if I multiply straight across, I get 70 divided by 7, which granted isn't that tough to do, but my point is always simplify if you can, and particularly in a case like that. I mean, obviously if I multiplied 35 times the 2, I would have 70x over 7, and that narrows to 10x. So, but being able to figure out that is the key in using this particular strategy.
So whenever I have denominators that are divisible, that can all be divided into each other, then I can
not quite stating it properly. If you can find a number or a variable that is divisible by all denominators, that's what you want to use. Well, I found it. 35. 35 is divisible by 35, it's divisible by 5, and it's divisible by 7.
Right.
I could have used 70 also. It's just not the least one. If I'd have used 70, it would have just made the arithmetic a little harder. So you tend to want to find the least one. But in the previous problem, notice what the least one was. In other words, this problem's a little harder because I have to realize, well, what's the least, I don't even want to call it a common denominator because I'm not actually going to add anything. What I want to do is find something that I can multiply both sides by that is divisible by that and divisible by that. And the only thing that is 3 times c plus 6. Notice that c plus 6 is not divisible by this. I could get away with it. I can multiply everything by c plus 6, but I'm still going to be left with a denominator of 3 right there. And if my goal is to completely get rid of all denominators, then let's multiply it by 3 times c plus 6. And then that will get rid of this entire denominator, and it'll get rid of that denominator, leaving me with a 3 times the 2c.
So it doesn't have to be the least denominator.
No, it doesn't, any more than it ever has to be the least. In other words, I can add these 3 fractions by just multiplying 8 times 4 times 3 and having 96 as my common denominator. There's nothing wrong with that. That's going to give me the correct answer. The problem is it forces me to deal with much bigger numbers. This now has to be 32. This has to be 20, 4 goes in. Notice how much more harder it is. 24, and this has to be 12. And now I get an answer that's 12 plus 24 plus 32, that's 68 over 96, and now I got to do a ton of math to simplify that. Whereas if I would have started with 24 in the first place as a common denominator, I would have been much better off. In other words, I don't have to just multiply all three of those numbers to find my common denominator. If I want a least common denominator, start with the biggest denominator and start increasing it until you find a number that is divisible by all three numbers. And that is 24. And that's all. In other words, first I try 16. That doesn't work. Then I try 24. If that wouldn't work, next I'd try 32. I just count up by eighths.
Okay.
Knowing that this is always going to divide into whatever I come up with.
Because it's the... Okay.
Well, because I'm increasing it by 8 each time. So the key is to find the number that's divisible by these two. And you don't get that until you...
We already know 4 is going to go into everything that 8 goes into. So we only have to find what 3 goes into.
Right, 3 and 4, yeah.
Okay.
Well, like you said, 4 always goes into 8. So you're right, we really only have to find out. We really could have answered it by multiplying 3 times 8 and done it real quickly. But there's a process for finding a common denominator, and I'm not sure everybody's taught it. And the way I just did it, I think, is the most efficient way to find the least common denominator. Start with your biggest number and just start increasing it by factors of that number.
Okay.
James, I have a 4:30 that I'm 2 minutes late for. I got to run. I will talk to you again later this week.
Sounds good.
All right. Bye-bye.
Bye.